Welcome back to Admin of Code 2025, Day 6, Trash Compactor. After helping the elves in the kitchen, you were taking a break and helping them reenact a movie scene when you overenthusiastically jumped into the garbage chute. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door has been magnetically sealed. As you try to find a way out, you are approached by a family of cephalopods. They're pretty sure they can get the door open, but it will take some time. While you wait, they're curious if you can help the youngest cephalopod with her math homework. Cephalopod math doesn't look that different from normal math. The math worksheet, your puzzle input, consists of a list of problems. Each problem has a group of numbers that need to either be added or multiplied. However, problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. Each problem's numbers are arranged vertically. The bottom of the problem is the symbol for the operation that needs to be performed. Problems are separated by full columns of only spaces. Left and right alignment of numbers within each problem can be ignored. So you go 1, 2, 3, 45, 6, and then you have to multiply them. The next row you add, and so on. Check their work. Cephalopod students are given the grand total. Adding together all the answers to the individual problems. In this worksheet, the grand total is this number. Of course, the actual worksheet is much wider. You need to make sure to unroll it completely so that you can read the problems clearly. Solve the problems on the math worksheet. What is the grand total found by adding together all the answers of the individual problems? Okay. So I can just map these columns. Super annoying to parse, right? Like that. Maybe I pre-process it. Oh, I'm so lazy. I'll just do this. I'm not bring anything. I'll just do this, 2 spaces, replace on, place on. Okay, so everything is now 1 space. And then life is easier. Now I can just go So it's just 4. I need to get here, this number, this number, this number. So I just have lines dot indices dot 4. No, lines dot 0 for each index, which is like the row. No, column. So I take one line, first one, take all the indices. Then take lines dot indices for each row. I go index like that, right? Column. Mm. Make a list. Mutable list of I mean, it's kind of like, it's called problem. Problem has problem has these parts, which is a list of int. Let's just start with long immediately, and then symbol or something, string or char or whatever. And then might actually do drop last one, and then I just map them. Ah, yeah, lines is not really a list of ints yet. Okay, let's do that first. Lines dot for each line. Now we can split in space, process lines. String, let's just cute string. Actually, it's just this, right? I have one list per line, which has the strings. Okay. Can I just call it lines? Okay, now I have these lines, and now I can say this to long, and then I can say lines dot last, which is like, no, not lines dot last, lines in indices dot last, which I can pop out. Last index is this one. So the what do I call it? Symbol is um, lines in the last index of the current column. Okay. Now I'm mapping these anyway, so I can say these are the parts. And I can say problem parts symbol. And then I'm mapping this. So this is my problems. Let's see. Now I'm curious if I have a nice representation of my problems. Yeah. Now I have a nice data structure where I can just see the things and then the symbol. So now I can just say problem dot solve. I have a cool function, problem dot solve. long. Mhm. Turns long. And when this dot symbol equals multiplying, then we have this dot symbol equals plus. And then we take the parts. Maybe we have to do much less harder. This is easy. Parts dot sum. Return. Here we do fold 1 x, y, x times y. Wrong symbol. Now I can do this. Now I can do this. Ooh, very nice. I do this nicer. Plus sum times fold. And we run it. And then we map that. Sums. No, solutions. And we sum those. And then what is the grand total? That should be this. And that's it for part 1. Now, part 2. The big cephalopods come back to check on how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read cephalopod math. Cephalopod math is written right to left in columns. Each number is given in its own column with the most significant digit at the top and the least significant digit at the bottom. Problems are still separated with a column consisting only of spaces, and the symbol at the bottom of the problem is still the operator to use. Here's the example again. Reading the problem right to left on one column at a time, the problems are now quite different. 4 where do we start? Ah, 4 and then 4, 3, 1, 6, 2, 3. Okay. And then the total was the grand total again. Cool, then we have to change, like this again. And then we just go parse it differently. Part 1. We don't really work now. It's just uncommented. Then we have part 2 where we have I mean, is it padded? That actually looks to be padded here. You can see it here. So I can literally just start at the end and read through it. Okay, lines, indices, well, line 0 again. Down indices, that's the column now. Kind of want to do the same thing where we can leave the last. The last index is the M symbol. Actually, it's not. Actually, we're like here, and then we have to walk left to find a symbol. Maybe I can say find symbol. Oh, they're like statically available anyway. Okay, then I can just say um, um, symbol. Let's say done equals if equals symbol equals space while not done. Let's get an index column. Let me check that one. Lines first. Let's just do this maybe. Then I'm gonna say while symbol not equals, while symbol equals this, I just walk to the left, check the symbol. If I have something that isn't equal to spacebar, I return it. Then I should find the symbol. Okay. Then I do something similar as earlier with each row we have, well, drop last, that's a symbol. We check then we check it. If line, well, we check while p is line, row, column. If p is space, we just ignore it. So not space. Okay, if it's space, and we do null. Else p not too long. Digit to int too long. Then we can do problem symbol parts. Problem parts symbol. Okay, this needs to be a string. Then we have problems. Well, problems is this. print it and check it out. See if it even works. 377. Hmm. Where's this failing though? I wonder if read lines does not pad actually. Let's check it. Yeah. Can we change it so it does it? And then, okay, what does it do? Max is line dot map dot length max. Actually, we can also just handle it, right? Mm, If lines row dot length last index column is kleiner than this, then we're good. Let's do when, then it's null. We have to do this thing. Maybe I should just do if then. If while index smaller equal to index smaller than last index length like this. Oh, greater than. No, greater than last index, last index. Okay. So if the index is greater than the last index, no, we just go one more. Still doesn't like it. I think this one is actually. No where it's happening. We're going, um, my head we were going backwards, we were going this way, but just fine. We just go 6, 4, 4, 4, and add them. See if we end up there. Part 0. Hmm. I mean, column is 0, the symbol is star, we find it. Somehow don't find any numbers. That's weird. Let's try, see what happens here. Row is 0, so last index in this row is 3771, my column is 0. Oh, I have another mistake here. If I'm greater than, okay, that's interesting. So now we can see the last one should be 5, 1, 2 should be the last one. Let's check it. 5, 1, 2, and plus. And we also have some empty rows. It's also okay. Okay, cool. So we just had some mistakes with our indices here. Here, and we're good now. Let's can we still solve it? Yeah, we can. And then we just do sum. And the number is really small, but that makes sense because all the in the middle numbers are smaller. It. We should still have something like that. Oh, maybe I'm wrong actually. No, I think I implemented it wrong. So I have 4 plus. So I did 4 plus 3 plus 1. But that's not what we want. We want to build a number out of 4, 3, 1, and then out of 6, 2, 3. Oh, okay. Damn it. Let's do that again then. So we have if we can just get away with it. Maybe we can just leave it and fix it. But that's also annoying. Let's just do it properly here. I think we could just map it to a different kind of. representation where we have a number. And we can keep a symbol. And then we just map it to problem part. Because we have like these digits, right? Let's just map the digits. And then we have number is parts join to string too long. Now we have, can't solve it now. We can print it and see what we get. Okay. Null for now. Okay, then we always have a null, and then we have a number. Okay, so each of those blocks is kind of like one thing that we want to do. So we can just take these parts, just go C small and then last index. See at the end. Then we just build another thing, which is the actual problems. These are problem parts. Can we go full problem is false. There we go. And then we have current problem parts. And then we go so we're always looking at this one, the current problem part. And if that part number equals null, then we found some kind of gap where we want to go problems. We want to add one full problem, right? Let's build it. Current parts, map their numbers. Um, okay, these are my parts. I can do one of them symbols, then we add that. Then we make current parts equals empty list. Else, so if it's not null, we just add to my current parts, problem parts, current one. That's it. Okay, and then we can print our problem and see what we get. So now we just took our problem parts and stitched them back together to be problems with parts. Then we can solve those problems, get the solution sum, and see if that's what we wanted. Too low. Okay, now I'm curious what happens if I get the example. I get 3 to 6, 3, 8 to 7. Something different. Let's check it. We have 124, 356 here. 3, 6, 9. Oh, interesting. We're missing a whole one. I guess the problem is that we never hit an empty one. So after we're done, we just go this again. We just forgot to add the last one because our code only checks if I reach a null again. Then I add the problem, and the last one I just collected and never added. So now if I go here, I should get the slightly larger number. And that's it for day 6. So yeah, part 1 was pretty simple. We just went through and added these numbers. So it's just a matter of passing it. It was really useful to have a data class that I can map to. So I have the problems with the parts and the symbol, and then you can see what's happening here after I mapped to it. I can just apply the logic for each problem and then sum it up. And then for part 2, it's a bit more tricky because you have to go make numbers out of columns. So the parsing is more tricky, but you basically just loop through the individual characters, check if they're valid, otherwise null. If they're empty string, you map null, and if there is something, you map it. And you can use this map not null to get rid of the nulls, and then you just have the parts, which you can then build numbers out of. So I map all of these and build numbers, which I can then use as problem part, which is just a number or null. And the symbol, which I just always go down and then to the left to find the corresponding symbol for my current problem. Then after I have all my parts, which is just a list of numbers, I can go through them, and based on having always this gap here, I can just say, hey, take these however many until the gap, apply the calculation to these numbers. Well, it's even simpler with having the data class problem where I can go through these numbers and just say, hey, map them into my problem. Then I can use the same logic from part 1, where when I have a list of problems, then I can just solve each problem by applying the symbol. So if it's plus, I do sum. If it's times, fold. So that's basically, you start with an initial value 1, and then for each 2 neighboring elements in the list, you go current one and the next one. Current one is current one times next one. So first one is 1 times first element in the list. We have 1 times that. Then you have that result times next one in the list, and then that result times the next one in the list, till the list is done. And you return that, and that's how you get the actual solution for each problem. And then we sum up all the numbers, the solutions. That's it for today. Enjoy the rest of your day.